This week's episodes were brought to you by the generous support of Yukofin. Hey you folks, Quilly18 here, and welcome to another episode of our Unity tutorial, codenamed Project SpaceCube, where we make a game about cubes flying in space. Right now we're working on a dust field. We started it last episode, we're continuing right where we left off, and we are writing the code for the script that's going to spawn all the motes of dust, but also keep them lingering around the camera to make a very cool effect. So what we want to do is, right now we're spawning them. We've got some number of dust motes we're going to spawn, which might be 100, might be way less, might be way more. We don't know how it's going to feel yet. And so we're going to spawn 100 of them, and we want them to be scattered around the camera to start off with. So the position of the dust mote is going to start based on the camera's position, and we want it offset by a certain amount, right? We don't want 100 motes of dust literally sitting on top of each other. We want them distributed in a sphere around the camera. I mean, I guess we don't technically need a sphere as long as the dust motes are in front of the camera. That's sufficient. But when the camera rotates, obviously there's going to have to be dust behind us. So it's better to just spawn everything in a sphere, and then, you know, we're in pretty good shape at that point. So how do we do that? We want to spawn at the camera's position, offset by a random direction, sort of in a spheroid kind of thing around the camera. Well, as it turns out, random has a couple of different functions, and specifically we'd be looking for inside unit sphere. This will give us a random vector, basically, you know, x, y, z, all randomized from -1 to +1. So what we're ending up with is a random position inside of a sphere with a radius of 1. So, I mean, I know it's weird because it looks like you would expect this to be a static property, but it's, you know, it's a dynamic property that returns a random number. To me, it almost should have been like sort of just set up as a function so it would look a little bit more explicit, but there you go. So this is a random vector ranging from -1 to +1 in all the x, y, and z coordinates in some randomized way. Now, offsetting just by 1 is probably not enough, so I think we also want a public, I guess we'll make it a float. We're going to call this the cloud diameter, or radius, cloud radius. And I think we're going to want it to be relatively big-ish. Let's call it something like size 25. You know, we'll start with that and figure out how that feels. So what I'm going to do is this, this random unit sphere, we're going to multiply it by this radius. And because of the order of operations, this gets multiplied first before it gets added to over here. But if you want some clarity, it's never a bad idea to just throw some extra parentheses on there to make it explicit that these two get multiplied together and then get added to position. So now we're going to be offset from the camera by a certain amount. So obviously we're going to use this dust mote position, add it in there. It also is going to want a rotation. I think a random rotation is going to be an excellent way, which we can do. So random rotation over here, so they'll be twisted. Although ideally, assuming we set up our dust motes correctly, then they will look rotated regardless, but let's go ahead with this. And I think it would be a very good idea, actually, if we make it so that this dust mote's parent is this dust cloud, this dust field object we're working on. We want all the dust motes to be parented or childed to the dust field. Therefore, it's not cluttering up our project. And I think that's a pretty good idea. Okay, so let's start with that and see what happens. Okay, we're going to, not that, we're going to go to here. Oh, we got an error. Cannot convert camera to transform. Oh, right, because it actually wants that. So we want camera.main. I guess we need to do something like this. If camera.main not equals null, then the camera, because it's the camera's transform. Transform. That's what we want. How are we doing now? Excellent. So if I hit play. Oh, I forgot to link the dust mote prefab, silly. See? That's why I put in those warnings. So right over here. The dust mote prefab. Oh, did I not rename that? I did not. Dust mote. There we are. So the dust field is going to have... Oh, it's not. It's doing the thing where it doesn't refresh it in the list. I think if I closed and saved, it would. But there we go. Let me rename it there so it just looks a little clearer. Drag you. So the dust mote prefab is there. I don't need to link to the camera. It will figure that out automatically, although I certainly could if I wanted to. But that's going to be fine. I'm going to hit play. And note, I'm looking for the camera, not the rig. Okay, so now I have filled the area with dust. And if I move, you can see the dust motes give me a real sense of movement, which is great. But at some point, I run out of dust motes because they are all behind me in that sphere that spawned around me. But it feels space dusty, right? I think it's good, and clearly our form is working. You know, if you get really close to one, and it's hard to get one to like literally line up right with the camera. You actually have to work at it. You can sort of see things, but you know what? It looks like a little starburst effect. I'm actually really convinced that that works out quite nicely. So we get some dust. Excellent. Okay, and they should render very fast because they all share the same material. There should be all sorts of dynamic batching going on, although that's something else that you could even optimize later on. Okay, so that's very good. We've got a dust field, but it doesn't follow our camera, right? It's good at first, but then we leave the dust field. So what we want is, if we want to make sure, I was going to say to spawn more dust as we move. That's not accurate. That's not actually what we're going to do. If any dust mote gets too far from the camera, reposition it to the other side of the dust cloud sphere. Right? So if a dust mote gets out of range, we're going to have it loop around to the other side of the cloud. So you imagine, as we're moving forward, some motes are falling behind us further and further, and eventually we'll get so far behind us that what we're going to do is we're just going to teleport it to the front of the camera again. So there's always going to be dust in front of us as we move forward, because the ones that are being left behind, we're just going to loop to the front. We could have them expire, we could spawn new ones, but there's all sort of overhead to destroying and creating game objects. Here, we're not going to be creating new game objects, we're simply going to be moving the ones we've already got. So we're going to assume that the cloud radius is what we're going to use for that. And so what we're going to do is we're going to loop through each one of these. And I suppose we can just loop through all of our children. That should work relatively quickly. So for int I equals 0, I is less than this dot transform dot child count. Okay, we're going to loop through each one of our children. We're going to look at a couple of optimization possibilities for that. We're going to loop through each one of our children, and we're going to say, is this child too far away from the camera? Right? That's easy to tell. So we can say, so this dot transform dot get child I dot position. Well, I guess what we want to do is a vector3 dot distance, a little helper to calculate the distance for us. We're going to take the child's position, and then we're going to take the camera's position. Okay, and this will be the if. So float the distance is equal to this. If the distance is greater than the cloud radius, yes, it's too far. Now, normally in these tutorials, I don't care too much about optimization because it's more important to be clear and everything like that. Having this float placeholder doesn't really add a lot of overhead. It's not too bad at all, although we could certainly, get away with it. There may be certain things we want to cache, but one of the more important things is, how do you calculate the distance of a vector? Well, what you're doing is you're doing, your classic theorem, right? Where you're doing the a square equals b square plus c square. Do you normally word it as c squared is equal to a squared plus b squared? You're basically doing that, although in a 3D kind of setting. That requires you to do powers. Powers aren't too bad. Power 2 is really easy to calculate, but it also requires you to do a square root to get the ultimate distance. Very, very sucky. Very, very, very sucky to do. Is there a faster way? Well, unfortunately, there's no, using vector3.distance, there's no way to avoid that square root, which again is quite slow. And if we're doing this 100 times per frame, that's not very good. Now, we don't necessarily have to check every dust mote per frame. There's a few optimizations we can do there, but it's probably a really good idea if, instead of doing the squares and then the square root, if we avoid that square root. How can we do that? Well, max distance squared, right? The cloud radius, if we multiply this by 2, we end up with the square of the cloud radius, and then we can just compare that to the square and save ourselves doing a root operation, which is very slow. So we can't use vector3.distance, but here's what we can do, right? We can have a vector3, which is the difference. So between the child's position and the camera's position, right? And the actual distance would just be the length of that vector, which normally you can get as the diff dot magnitude, right? The magnitude is the length of the vector, which is the distance between the two, which is what vector3.distance does for it. But you may have noticed that there is a square magnitude in here, which is basically the magnitude without doing that square root. It saves that square root. So what we can do is compare, hey, is the difference square magnitude greater than the max distance squared? So now we've just avoided a little bit of an operation. And there's way more you can do in here, but I think that's as much as I'm going to do because I still like, you know, being a little bit explicit with the variables in these tutorials. But yeah, we say, yeah, that's too far. So let's flip the dust mote to the other side of the camera. And we can do that. I just realized there's something a little bit wonky with what I'm describing here, because we could get some weird, awkward blink back and forth. Anyway, let's deal with that when we get there. So the easiest way to do this is to say, okay, let's say that this child's position, and already you can see I'm going to use this reference a second time. How fast is this? It might be really fast. It might not be really fast. It might be a good idea for us to say transform the child is equal to this, right? We're not instantiating anything. There's no garbage cleanup. We're just holding a direct reference to that child. So we're not having to use get child anymore. It's probably pretty fast, but I don't know. It might not be, right? So we'll just use this. There we go. If you're going to refer to something more than once, cache a copy to it rather than looking it up twice. So instead, we're going to set the child's position to be equal to the camera's position plus the negative of the difference, right? So imagine the situation where the camera's at 0, 0, and we are at, say, 1, 1, 1. Okay? We are at 1, 1, 1. So difference is equal to 1, 1, 1 right now. And we've determined that that's too far away. That exceeds our distance. So now we're going to set the child's position, which is currently at 1, 1, 1. We're going to set it to the camera's position, which is 0, 0, 0, minus, I guess that's a better way to do it, minus the difference. So we're going negative 1, 1, 1. So that means our child's position is now going to be at negative 1, negative 1, negative 1. We flipped it to the opposite side of the camera's position. So again, we've sort of taken it from behind us and put it in front of us. Now, there is one sort of weird situation that will come up here in that it's still, at this point, it's still bigger. Assuming the camera has stopped moving. Let's say the camera just took a step forward and then stopped. And then we run this test. And there's an object that was too far away behind us. So now we flipped it in front of us. But the absolute magnitude is still the same. So the next frame, even though this thing's in front of us, we're going to be like, oh, it's too far away. So we're going to flip it to the other side and back and forth and back and forth. Which may not actually be a problem, assuming that this is all happening so far away that we don't actually see it happening on the screen. But if it is happening in a visual part of the screen, you get something that sort of blinks on and off, which is not really ideal. So it's probably a good idea if we do something like this and say, hey, vector3, new position is equal to this. And then new position dot, I guess we don't clamp it that way. We're going to use the static vector3 dot clamp magnitude. Clamp magnitude takes a vector, and then we give it the maximum length, which in this case would be the cloud radius. And we say you're not allowed to be bigger than this. So this makes sure the new position is a distance such that it won't trigger this again instantly next frame. So you won't get the back and forth wobble, which might eliminate a bit of a visual thing. So again, this is probably something that can be relatively optimized, but this is probably okay as long as we're not doing like 10,000 dust clouds. We'll see. If you're playing on a mobile device, then you may want to check to make sure that this is not, you know, taking up too much CPU or GPU or anything like that. But let's give this a try. So I'm gonna hit play. My dust cloud. Now I'm gonna move forward, and as I do, see this? More and more dust arrives. Now there's, I mean, a tiny bit of a pop in. Ooh, burr. Am I still leaving it behind? Brah. Oh, Clearly I've messed something up. Hold on a sec. And hit play. Should be very obvious what's going on here in the... Oh! Why is all the dust in there? Look. I'm doing something wrong. I'm definitely doing something wrong. What the heck's going on here? And just keep an eye on the what's going on over here. As I back up, okay, it might be hard to see. If I can click on one of these. I'm going to click on you. There we go. This dust mode, okay? Look at what's going to happen as I back up. At some point it's too far away and it spawns there. That's great. But if I click on, say, this guy, there we go, and I back away, at some point it gets too far away, it gets mirrored to the... But it's too far. And then ultimately everything ends up going right there. Why is it? Child's position, which is not the local position. There's no way it's the clamp. I'm sure it's not. I mean, I'm not sure, which is why I'm going to do this. No, there's something else. There's something obvious, and as soon as I'll see it, I'll be like, oh, that's what it is. I'll slide backwards. Oh, it is the clamp. There we go, because now, if you look at the moat, it is going to clearly and correctly mirror to the other side. Oh, derp, 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 derp. Okay. What I'm clamping here is the magnitude of the new position relative to the origin. Yeah, okay, so I'm screwing up. Yep, okay. So what we want to do here, we're nearly there. Oh, right, of course. So this is correct because yeah, how do I best word how I F this up? So when you're doing the clamp magnitude, it's taking a vector. Well, the vector it's taking is my position, like my vector as a position, not relative to the camera, but relative to the origin of the world. So it's never letting us get further than 25 units away from the origin of the world, not the camera. So what I actually have to do before I do this is I have to change diff, and I have to clamp diff to be the cloud radius. So we are never going to be more than, if cloud radius is 25, then diff is never going to be longer than 25 after this operation, which means when we go to the camera dot position minus diff, we're never going to be more than 25 units away from the camera, which is correct. And again, if we take a look at the dust field over here, zoom, 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 zoom. Right, there's the camera position, there's the dust field. Now, the dust field may be hard to see, but keep in mind that I'm looking at one of the dust motes over here. If I go and I can turn, oh, even, oh yeah, because I turned the rig. Ah, that's quite interesting. Yeah, there we go. So that's correct. And it's going to warp to the other side. There we go. And always be above 25 units away from the camera in some fashion. So I've got this dust field around us. Now, this is very, very tunable. And actually, we went and made it relatively tunable just with the numbers over here, right? I can add more or less dust motes. So let's say I make this 1,000 dust motes. All right, hit play. We're going to have a much dirtier sort of environment over here. And to me, that's too much. That's too much, but I don't know, maybe not, right? So you make it 100. You could add in some variety. This all of a sudden starts to feel a little bit like, hey, are we creating a particle system? Yes, actually we are. And in fact, you could use the particle emitter engine to do something that may satisfy this. In fact, like if your movement rate was never going to be very high, I actually would just use a particle system with relatively long-lived particles to do this. But since we can go quite quickly, there would be certain like edge cases, and especially when you get to high speed, where the particle system just wouldn't really be able to generate something that looks anywhere remotely close to correct. So doing our own sort of particle system here is better. I mean, literally, these are particles. They're dust particles. So we can tune that. We can tune the radius. The other thing you could do is you could have things fade in and out. You could have these things each have a little bit of their own sort of maybe spinning or movement or drift or something like that. I don't know if that's exactly what you're looking for. And you can also improve things a little bit with a custom shader that would add fall off, so that the dust that's far away is considerably more transparent in that, see that where you do see some pop out, right? When I go and back up, at a certain point, the dust disappears because it's warping behind us. Now, there's two ways you can, make that less of a problem. We can make the cloud radius a lot bigger, which you really would want to pair with like a lot more dust particles, right? So now, they get quite far away, and they're so far away that they're very tiny and basically invisible. But that, that adds a lot of overhead. Well, does it? I don't know. Maybe it's like trivial to produce this much dust. It depends on your video card, your CPU, and how Unity is optimizing things. But you could do that, and actually it looks pretty good. But you can actually fake that pretty well, as long as you had a system whereby particles that are basically at the maximum distance, let's say we set our radius back to 25, right? Particles that are 25 units away from the camera are basically transparent, which you can do because, well, yeah, well, that's interesting. Yeah, we really would have to make a custom shader, because for most shaders, you can add in an extra visual effect. Not texture type, but the material over here. You can add a color component to this and multiply the transparency by the color, or you multiply your texture by the color component, and that can include an alpha slider. So basically, in your script, you would be constantly updating the material for each individual dust mote to increase its alpha based on its distance from the camera. The downside with that is that you can't batch things as well. If we hit play over here, you can see, let's see, how many, where's the draw calls? Render thread, batches, save by batching. But it doesn't actually just list draw calls anymore? Really? But what it's doing, it's actually combining a lot of our dust together, or it should be. Set pass calls. Yeah, I used to just say draw calls. But anyway, the most intense thing when it comes to drawing something to the screen is the number of objects. It's actually deceptive. It's not really the number of triangles, it's the number of objects, because you can actually send a lot of triangles to the video card in one go. Very optimal that way. But that only works if everything has exactly the same material. If you start having shader set up such that each individual dust mote has its own instance of the material that is being alpha blended based on distance, then that becomes no good. But actually, I guess we wouldn't do that. No, we wouldn't do that. We would just have one material. We would make sure the material knew where the camera was relative to, well, each vertex, basically, just giving it the camera position, which actually we don't even need to send that explicitly. Every particle will know its distance from the camera, and then we could have it do the blending there. So actually, we could still do the batching. I think we actually might look at... yeah, because we don't need to send a material. We just need a shader that's smart enough to say, if I'm far enough from the camera, I want to start dropping off. I guess we have to tell it what the maximum distance is. That's true. Right? And we'd want that to be in tune with the distance of the dust field. Because whenever the cloud, a particle is more than this many units away, we want it to teleport to the other side. But what we probably want to do is have it so that when a particle is somewhere from say, it's fully visible from, say, distance 0 through, I don't know, 20. But as when it hits 20, it starts to fall off until it's 25 units away, at which point it's fully transparent. And we want that sort of logic. So we'd still have to give that in. I think we might make a shader next episode. I think that could be fun. We've worked with shaders a little bit before to make cool wobbly edges. Here we're just going to do a simple fall-off shader that starts at a certain distance. And I think that sounds fun and lovely. So we're going to do that next time. Thanks for watching, folks. I'll see you then. Thank you, October patrons. Those are the people who pledged in October and who are supporting these videos from November through to early December, and especially these Mic Check supporters. We've got Yuko Finn, Adam Conway, Drazian, Jan Torivel, Adjective, Michael McClintock, Aaron Toyson, Craig Mortel, Stephen Wendell, Julien Auger-Lafont, Marius Fielvold, Speedy Savant, Valiant Cake Fiend, Wes Oldenboiving, Jason Yanity, Kale the Quick, Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you very, very much.